Hi, welcome back. This is part 3 of my DIY bed leveling sensor build. In the former episode I built the sensor to the level that only the Hall sensor was missing from the PCB, and I didn't put the magnets to the 3D printed parts yet. So this is what we will do in this episode. If you remember, in the former video I made a mistake and I fixed the PCB too early to the 3D printed parts. This made the Hall effect sensor fitting very difficult. Instead of showing the suffering in that build with the Hall effect sensor, I printed the 3D printed parts again and I soldered the Hall effect sensor to an empty board. This way I can show you how to do it in a proper way. So let's get started. Here are the new 3D printed parts. I already glued the spacer to the base, and I also have the pins, the toothpicks in place. So this is the empty board that I will use for demonstrating the Hall effect sensor build or installation. Please note that I clipped the toothpicks short, so this makes it easier to move the board back and forth. Alright, so we will put the Hall effect sensor from the bottom side, and the curved part of the sensor should face downwards. This is a bit tricky because the pins of the Hall effect sensor are too close to each other. But once you manage to put all 3 pins through, just push the sensor all the way down to the board as long as you can, like this. And then on the other side I align the pins so that they are parallel to each other. So this way they will be spaced properly for the board. Okay, once this is done, just put the sensor to the board and we will fit it to the 3D printed part. So the whole board will go to the 3D printed part. And now you can move the sensor up and down by just pulling on the pins. So pull it in all the way, so this way you can slide in the sliding rod and you can push back the sensor into the cavity. You can use a pair of pliers to align it. The aim here is to pull it up that it is almost at the top of the sliding rod. And it is aligned so that the sliding rod can move freely. Now before soldering the sensor, it will not move freely, so it's probably binding up. So what is important here is the height, so the length of the pins of the sensor. So now I'm just soldering the pins to the board. then we can test if it binds up. So probably the pins or the sensor itself is touching the 3D printed part. So I use a pair of pliers again to align the pins, getting them closer to each other. But be careful not to short the pins. Maybe it's a good idea to put some insulation on the pins. I didn't do it. It works this way as well, but you can do it if you think. So you just once the pins are aligned properly, the sliding rod should just slide. Now we are switching back to the original build, so all the parts are on the board, and now because I had to break the pins for the Hall effect sensor alignment in this build, I just glue the board back in place. And for you, this is the good time to melt down the pins, the toothpicks, and fix the board to the 3D printed parts. But don't forget to put the sliding rod in before you do that. So I just remelt the toothpicks here just to have a better fit. Now I'm doing some tests. This is just a servo tester, and I connected the pins necessary for the servo. So you can see it's the signal pin, the 5 volt and ground is connected to the sensor. The next step is put in the magnet. So I'm using neodymium magnets. The diameter of the magnet is 5 millimeter, and the thickness is 1.8 millimeters. The first two magnets are situated in a way you can see it on the screen. So the north pole of the magnets are pointing towards the Hall effect sensor. If you wonder which one is north or south, if the compass pin points to north, that end is attracted by the south pole of the magnet. So put in the magnet so that the north pole of the magnets point towards the Hall effect sensor. So south, north, north, south. The two magnets are repelling each other. So here I put the next magnet, which is closer to the air gap. So this will act as one part of the magnetic spring. And this is aligned the same way as the one below. So north downwards and south towards the air gap. Okay, here I connected the output of the sensor to my multimeter. And as you can see, when the air gap is closed, it shows 5 volts. When I open it, it shows 0 volts. So the Hall effect sensor and the comparator works properly. I just fix the magnet with a drop of super glue. So here I just show again the layout. So south, north, north, south, north, south. Here I install the last magnet, which is going to the stationary part. and it is repelling to the last magnet. So north is up, south is down. So this way the last two magnets are repelling each other and they act as a magnetic spring. I just test the output of the sensor again, and as you can see, when I release it, it just slides down because the magnets are pushing. So here is the complete layout on the screen. And basically that's it. At this point the electronics are completed. Now what remained is just to attach the servo. Please remember that the servo shaft is closer to the top. I cut a plastic toothpick to 2 pieces exactly in the middle, and I just push as much as I can and then cut the toothpick to the right length so I can melt both ends down. So about 2-3 millimeters. Okay, when everything looks good, I just melt down the toothpicks. Meanwhile I'm doing it, I'm pressing the 3D printed part and the servo together. Now I test again just the servo part. So I connect it to the servo tester once again. So I'm just putting the servo arm on the servo and I start rotating it. Now you can see the servo arm is just barely long enough, so maybe later it would be a good idea to design and print a bit longer arm. Okay, so now I turn the servo all the way to the end and then put the arm on top. So when I move, I cannot over rotate the servo. Okay, release and close. Release, close. It works as expected. So with this, the sensor build is almost complete. Only thing that is missing from the sensor is the pin on the bottom of the sliding rod, which will be again a plastic toothpick but I will just glue that and cut it to the right length when I assemble the sensor to the 3D printer. Thanks for watching. Bye.